It's a dirty world out there, and today on DFTV, we're digging up the dirt on pollution.
It's clear.
Finding silver linings in socks. And growing skateboards.
So are you our friends?
Major funding for DragonflyTV is provided by the National Science Foundation, supporting education and research across all fields of science and engineering. The National Science Foundation, where discoveries begin.
It's a lot of fun. Number one, you might learn something to tell someone. It's Dragonfly TV. Dragonfly TV. Let's go, Dragonfly TV. Dragonfly TV.
I'm Eric, and today's show is brought to you by All Things Nano. You can't see nanoparticles, and even though they're super small, just 1/1000th of a meter, they have started a revolution. A couple hundred years ago, big machines started a different revolution called the Industrial Revolution. Before that, people made things with their hands, but then factories came along, and the assembly line totally changed the way things got made. Now, nanotechnology is using tiny particles to make cool things that can change the way we live. So that is a revolution too. And some of these nano inventions may actually help the planet stay healthy. Think about all the trash that piles up. Plastic that never breaks down is a big problem. And scientists are using nanotechnology to create a new kind of plastic that decomposes in just a few weeks instead of 1,000 years. And that might save us from this. And you know what? The nano revolution may be happening in your own backyard. Whew. Check this out. Gabe and Taylor are investigating how nanoparticles can clean up a giant mess.
I'm Taylor.
And I'm Gabe.
And this water used to be very, very polluted.
But now, it's pretty clean.
We love the water. We know that keeping it clean is not always easy.
Just upriver, there's an old zinc smelting plant that was one of the factories polluting the water. And even though it shut down, the land there is still full of toxic stuff.
So we've been wondering, can pollution from places like that be stopped from running into rivers and streams?
We thought we might be able to learn more about the Palmerton pollution problem at the Franklin. That's the Franklin Institute in Philadelphia. They have tons of really cool exhibits.
Hi guys, I'm Jayatri.
One of the museum educators told us how they are cleaning up pollution using a special kind of iron, nano iron.
If you look closely, you can see that we've got sand packed in the middle here. And I put in some iron flakes into the top. Can you see if the iron flakes are making it through the sand?
The big iron doesn't go all the way through.
No. So nano iron is special because it's a lot smaller than those iron flakes. Gabe, I want you to pour that nano iron into the tube here. So as we watch, you can see that the nano iron is filtering through and coming through the bottom.
A model of the soil showed what a difference the size in particles makes.
So I get it. The big iron doesn't fit through the ground.
But the nano iron can go all the way through and attaches to the pollutants.
Do you think we might be able to take some of that nano iron to do some tests up at Palmerton?
Ah, so you've heard about the pollution up at Palmerton. Well, I think I got some friends at Penn State who might be able to help you out.
On our way to the Palmerton zinc plant, we passed rivers and creeks that used to be really dirty from the steel mills and other pollution.
Ta-da!
The old Palmerton zinc plant is a sad waste of a place where you don't want to hang out for long. The pollution from the site killed plants and animals in the area and is still sitting in the soil. We looked around and met up with Joanna, a scientist from Penn State.
Hey. Hey, hi guys. I'm Joanna.
Joanna's on the team that's working to clean up the Palmerton site.
About 10 years ago, This landscape was all barren because of the zinc smelting that went on here. But the vegetation is coming back slowly, as you can see.
So, with all this pollution in the ground, does it get to the groundwater?
Yeah, it does, and that's a big problem because once it gets into the groundwater, it can get into wells and other sorts of drinking water.
Would nano iron work here to clean it up?
Absolutely.
Joanna told us that when you inject nanoiron into the soil, it attaches to pollutants and heavy metals in the soil and groundwater, just like we saw at the museum. We got out our shovels and took a soil sample.
Is zinc the only pollutant in this ground?
Well, there definitely is a lot of zinc from the zinc smelting, but other metals like lead, nickel, and copper are really more dangerous to us. Are you guys ready to take this to the lab?
Yeah. What I like about working with Gabe is that he's Gabe.
And here's Gabe. I see the resemblance.
Likes to make jokes.
Splish splash, I was taking a bath.
Makes it more, the atmosphere a lot lighter. What will the nano iron do to the Palmerton dirt?
Stay tuned for the magic of chemistry.
It's hard to imagine hundreds of acres being cleaned up by tiny nanoparticles, but that's part of the nanotechnology deal. Super small can be super powerful. In today's challenge, we meet another common metal. When you make nano-sized particles from this metal, it can be used to help fight disease. The question is, what is cancer's new nano-enemy? Is it A, gold, B, tin, C, mercury, or D, aluminum? Try to figure it out. I'll be back with a clue later on and the answer at the end of the show. Now back to Taylor and Gabe as they measure the cleaning power of nano iron.
We met up with Joanna back at the Penn State campus. She explained to us that we could run a test on the contaminated soil samples from the Palmerton site to see if the nanoiron would clean them up. Joanna let us use her lab at Penn State to check our samples. We lined up all the equipment and got to work. First, we mix our soil samples with some chemicals to get them ready for testing.
We're gonna put our soil on the tumbler to mix up the solution and the soil.
As they mix, the acetic acid will pull the metals out of the soil.
These soils will be tumbling for around an hour.
Let's play soccer.
That's why I'm skating with Joanna.
We separated the liquid from our contaminated soil samples. Any pollutants that were in the soil would now be in the liquid.
Still rusted from all the metals inside of the ground.
We finally had the liquid for our nanoiron test. Next, we added nanoiron to one of our polluted samples.
Good job.
All right, let's go back to the tumbler and tumble these for an hour.
It was time for the nanoiron to do its thing.
Well, I think science can be funny because anything can be funny as long as you put a little humor into it.
No, scientists cannot be funny.
We went back to the tumbler to check our samples.
Holy mackerel, it's clear.
Just because they're clear doesn't mean the nano iron got all the stuff out.
We went to another lab to analyze our samples.
Right here is the atomic absorption spectrometer. All right.
The spectrometer uses a flame to measure the amounts of metals in a sample. We measured the amount of copper, lead, and nickel in both our treated and untreated Palmerton samples. It worked. The nanoiron had removed a large amount of the copper.
It's amazing how the little bit of nanoiron really helped clean the water. That's such a big difference.
It's a huge jump.
When we were finished, we took our results and put them on a chart that showed how much of each metal was in the samples before and after being treated by nanoiron.
The nickel is 1.52.
What's after?
0.4.
Yummy like a gummy bear.
To help us understand the results in our chart, Joanna showed us the concentration of metals that are safe in drinking water. In the untreated Palmerton sample, the copper was almost 5 times higher than what's safe in drinking water. And the lead and nickel weren't safe to drink either.
It's kind of scary to think that that much metal could be in the groundwater.
After the nanoiron treatment, the copper levels in the Palmerton sample were okay for drinking water. The lead and nickel levels dropped a lot, but they still weren't quite safe for the water we drink.
Well, from our findings, it seemed like it only worked partially.
That's really true. You would probably need to couple nano iron with other sorts of cleanup technologies to make sure our water is safe.
I think we're going to have to do a lot of other tests on a lot of other soils to see if the nano iron works.
Wow, you guys really seem like you're into this.
Well, it's a dirty job, ma'am. Someone's got to clean it up.
Thanks, Joanna. Now that we know pollution can be invisible, maybe we should test the water quality here.
Well, Joanna said we can go back anytime.
Yeah, cool, but I know a test we can do right now.
And what's that?
What are some other ways that nanotechnology might help clean up the planet? Well, some nano engineers are working on a special kind of paper towel to mop up oil spills. This is how a regular paper towel drinks up oil and water. But check this out. A towel with ultra super special nanofibers drinks up 20 times its weight in oil and leaves the water behind. And the best part is, the nanofiber towel can be reused again and again. Reduce, reuse, recycle. Nano style. And next, the ultimate in good green fun. Anil is developing a skateboard that you could eat. Well, almost.
Let's go!
Well, my name is Nanotechnology. I'm a research scientist, and I helped design this environment-friendly skateboard. This is what we use for making skateboards. This is a soybean plant, and these are the soybean pods. We extract the soybeans, and we use it to convert into resin, and that acts like a glue. Soy is our friend. We have here Senthil, a graduate student in our lab. After the soybeans are harvested, the next step is to extract the protein and use nanotechnology or nanoparticles such as nanoclay,
soy protein,
nanocellulose from wood. And once that is all added, we have a strong glue that keeps the skateboard glued together. What we do is to do the basic research behind the skateboard, and the skateboard company, of course, makes all the skateboards. Hello, this is Jason. He's the president of Comet Skateboards, and this is the place where the skateboards are made.
Yeah, so the focus of what we do at Comet Skateboards is we take locally grown hardwoods, locally grown soy, and we assemble everything here piece by piece. We take the hardwoods and combine that with the resin, put that in a press, and gets pressed at over 50 tons of pressure. Until that resin and that wood cross-link and bond together so that they will never split apart.
The soy protein is completely biodegradable. If you put it in a compost medium, it is gone to absolutely pure organic soil in about 4 months or so. Skateboarding was new to me. I don't skateboard, but I try. Look, I'm not a skateboarder, but I've been playing badminton for many, many years. Here at Cornell, we have a lot of young students, and I can give them hard time.
Let's get ready to rumble!
I think 10 years, 20 years, if we can use everything sustainable to create a fully sustainable economy, I would be very happy.
Anil's skateboards show us that nanotechnology can be part of keeping our planet healthy. Other green nanovations will help make better solar panels, paints that change colors to absorb or reflect sunlight, batteries that make motorcycles like Kilocycle more energy efficient, and the list just keeps growing. Now back to a different breakthrough and today's challenge. What is cancer's new nano enemy? Is it gold, tin, mercury, or aluminum? Here's a clue. This metal is solid at room temperature, it's very soft, and it can easily be pounded as thin as this leaf. Keep on thinking. Next up, today's Zoom Cab ride is on a bike. Aw, no, Zoomer, you're not being replaced by a bike. We're just zooming into one. Check this out. This bike's handlebar support is made of a lightweight carbon fiber. Let's zoom in for a closer look, shall we? Its crisscrossing fibers make it strong and flexible. In each strand, there are thousands of separate carbon fibers. Looks kind of like a giant fistful of uncooked spaghetti, doesn't it? I know, Zoomer. Makes me hungry too. Where each spaghetti-like strand is snapped, you can see the fiber ends. And those grooves along the side of the strands, those help the fibers stick together with a special kind of glue. Let's zoom in for a closer look. You see that stripe that looks kind of like a river? That stripe is made up of layers of carbon atoms. And these dots over here, those are the same layers just seen from above. Looks like we're heading into a carbon beehive. And those fuzzy dots right there, those are individual carbon atoms. I know, Zoomer. Let's put it in reverse. So next time you see a cyclist flying by, shoo, they may be riding carbon spaghetti. Yep, the nano world is full of surprises. Next up, Sarah and Monday find out that when it comes to socks, all that glitters is not gold.
Hey, I'm Sarah.
And I'm Monday.
And this is our story. Once upon a time, there was a metal called silver. It was discovered that silver could kill bacteria on food and in drinks. No one understood how it worked, it just did.
Long ago, ancient Egyptians put their food inside silver containers to keep them from spoiling.
Ancient Greeks and Romans kept their water in silver goblets to keep it fresh and clean. Chinese emperors ate with silver chopsticks.
Americans used to put silver dollars in milk.
During World War I, silver leaf was even used to help fight infections and heal wounds.
The next stop in our silver story was the Science Center in Ithaca, New York.
It's a great museum, and they have all kinds of fun exhibits. Look, nanotechnology. We checked out a couple of exhibits all about nano. Dr. Monday.
Then we got to the nanosilver display and learned that scientists are using nanosilver in bandages to help cuts heal faster.
What? Nanosilver?
We wanted to learn more, so we met up with BJ. He's a museum services coordinator at the Science Center.
Silver that scientists used to use, was very big. It's called macrosilver, and it's something you could see with your own eyes. But scientists say are using a different kind of silver. It's called nanosilver, and it's stuff that's so tiny you have to use really, really powerful microscopes to look at it.
So what's with this green guy?
Well, this green guy here is our model of Bob the bacteria cell.
We compared how many pieces of silver we could put on Bob the bacterial cell, with big beach balls to represent regular silver and little wiffle balls to represent nanosilver. I can't even see bacteria with my eyes, and nanosilver is smaller than that. We could only fit 3 regular-sized silver pieces on Bob, but tons of nanosilver stuff.
Get the idea? The same amount of silver can actually kill more bacteria because of how small the size is.
So that's why nanosilver kills even more bacteria than regular silver.
That's correct.
BJ told us that nanosilver is being used in different kinds of products to kill bacteria.
Those bacteria let off some funky odors. So we put in some nanosilver particles in the shirt to help keep those things down.
But tell me, what happens when the nanosilver is washed down the drain?
Well, some people are worried that nanosilver particles might end up in the environment and actually kill some good bacteria out in the wild.
Thanks so much.
You're welcome.
We decided to visit a lab to test out how nanosilver affects the environment. But first, we had a test of our own to see how good nanosilver is at killing bacteria and bad smells. It was time to put a nanosilver product to the test.
Nano socks!
We went to the sporting goods store and bought 1 pair of regular socks and 2 different brands of nanosilver socks. Do they really smell less than regular socks?
I know how we can find out.
How?
A smell test.
Okay, so let's put one nanosilver sock on one foot and a regular sock on the other foot. The object is to get our feet and socks as sweaty as we possibly can. How high can you go? Get it from me. Getting tired, Wanda?
No, are you?
We played for a really long time and got our socks as sweaty as possible. It's time for the final moment of truth, the smell test.
I got stanky socks.
Our socks all smelled about the same, like sweaty socks. Smell test results, inconclusive.
Next up, we wanted to test whether nanosilver washes out of the socks when you put them in the laundry. We remembered what BJ said.
Well, some people are worried that nanosilver particles might end up in the environment and actually kill some good bacteria out in the wild.
We washed one of each sock and saved the dry socks for later. Now let's take the socks in the water to the lab to see if any nanosilver has leaked out. We went to the Department of Microbiology at Cornell University to meet a student named Hekia, who tests nanosilver fabrics.
Hekia helped us test our nanosilver, both the silver in the socks and any silver that might be in the wash water. First, we did a bacteria test on our clean, dry socks to see how well the socks killed bacteria.
We used a common type of bacteria called Micrococcus.
Micrococcus is bacteria that's commonly found on your skin, and it's actually the reason why your sweat will smell.
First, we cut out samples from our dry, plain cotton socks and our 2 pairs of nano socks.
We put the socks on an agar plate to hold our socks in place. The agar looked a lot like gelatin, and it had some bacteria food in it. Then, we combined the Micrococcus bacteria with liquid agar and poured it in the plate with our socks.
Okay, guys, now we'll test the wash water.
We wanted to know if the leftover wash water from the socks could kill bacteria too. We had samples of wash water from all 3 of our washed socks.
We took each of our wash water samples and mixed in bacteria and some broth for the bacteria to feed on. We put all our socks and wash water samples into the incubator so they could stay warm and grow overnight. Okay, so here's the regular sock. It's almost as if there's a sheet of yellow bacteria over it. The regular sock didn't kill any of these bacteria. Both of the nanosilver socks have a ring around them where no bacteria grow.
It's just like the bacteria is not even allowed to touch it.
They both did their job and killed the bacteria.
Then we checked out our wash water samples. The water from the regular sock and one of the nanosilver socks was full of bacteria, so it looked cloudy, but the water from the other nanosilver sock was totally clear. Something must have leaked out of the sock to kill the bacteria.
So does that mean that the socks are leaking nanosilver into the water?
We do know that nanosilver kills bacteria, so it's possible that's the case. However, to prove that, we'd have to run a bunch more tests.
Well, I guess that's an investigation for another day. We still don't have all the answers about how silver works. But now we know that nanosilver has a lot of cool possibilities. If scientists can figure out the best way to use nanosilver and protect the environment at the same time, it'll be a happy ending. The end.
So those 2 were great nanodetectives. I guess anyone making new products with nanoparticles has to do a bunch of tests. But before nanosilver came along, we knew silver had its pluses and minuses. Like Sarah and Monday said, people have been using silver to help cure infections for a long time. But too much silver in the body can cause a skin discoloration called argyria, which turns the skin blue-gray permanently. Silver has a lot of practical uses too. It's used in photography, it's good at conducting electricity, a silver bullet can kill a werewolf, its chemical symbol is AG.
Will nanotechnology benefit all people equally?
Let me think about that.
Of course not.
Some people might benefit from nanotechnology and some people might not. Well, I think that nanotechnology could never really benefit all people equally because of the fact that some people have more money than others.
With nanotechnology engineered products being more expensive, then people who don't have quite as much money wouldn't be able to buy these products.
It should be available to everyone. When everything starts getting made out of it, it won't be that expensive.
A lot of technology is that way, that it gets cheaper as they know more about it.
Eventually, maybe the poor people will get it, but it might take longer.
I think there should be laws that make nanotechnology accessible to everyone.
I think it will definitely benefit us all in the long run.
Cut! If everyone could access nanotechnology equally, then it would be fair.
Those kids had some great ideas. Tell us if you think nanotechnology can help everyone. Go to our nano message boards to post your ideas. Here's how. Click on over to the Dragonfly TV website at pbskidsgo.org. Stream a cool DFTV video, try your hand at the new Nanobots game, or tell us what you think about nanotechnology. It's your place to share your ideas. Now it's time for the answer to today's Nano Challenge. What is cancer's new enemy? Is it gold, tin, aluminum, or mercury? It's gold. Gold has been used in medicine for a long time, but when it's nano-sized, gold has all sorts of new properties, and it's been discovered that gold can help treat cancer by targeting only the cancer cells and leaving the healthy cells untouched. That's much easier on the patient than what's being used now. Yep. Gold is a superstar of nanoparticles because it can be found in everything from medicine to electronics to clothing to cosmetics. So the nano revolution lives. Here are some ideas that may be ready to use soon. This carbon nanotube helmet is super strong and light, and it has nano sensors that give weather reports and directions.
It's 65 degrees.
Thanks. This waterproof jacket changes color and turns fluorescent at night. Cool. I can check text messages on this nanofiber phone and pop it onto my wrist. Sweet. Here is a roll-up TV screen. For watching Dragonfly TV, of course. And now, for the fog-proof shades. And finally, my favorite, the Comet skateboard. For a very cool and a very green ride. See you soon for more breakthroughs on Dragonfly TV.
Major funding for Dragonfly TV is provided by the National Science Foundation, supporting education and research across all fields of science and engineering. The National Science Foundation, where discoveries begin.